This is section 11.5, areas of similar figures. List two headings you would use to make an outline of this lesson. So looking in the book, the first heading I see is areas of similar figures. And the second one I see is scale factors in similar figures. So we might note that we had before scale factor was represented by the letter K. We said if our K was bigger than 1, it was an enlargement. And if our K was smaller than 1, it was a reduction. And we found that K by making a fraction or a ratio of the corresponding sides, which we're going to do in some of these examples again. So part of this should feel a little bit like review. Define similar polygons in your own words. Well, similar polygons are different than congruent polygons. Congruent polygons have both the same shape and the same size. Similar polygons have the same shape but not the same size. We would say they're similar if they have the same shape, and more specific than just saying different sizes, we could say all the angles are congruent, but all the sides are proportional. And when we make those ratios of the corresponding sides, we know that they're proportional because we have similar figures, and we know the ratio of the corresponding sides gives us our scale factor, our K. Fill in each blank with the correct term or phrase. A slice of pie would be an example of a sector of a circle. A figure or shape enclosed by another geometric shape or figure is inscribed. So enclosed or inside describes the figure as inscribed. And lastly, a segment of a circle is the part of the interior of the circle bound by a chord and an arc. So if this was my circle, this was my chord, and this was my arc, this portion inside would be the segment of the circle. Similar is a word that is used in everyday English. Find the definition of similar using a dictionary. Explain how its English definition can help you understand its meaning in math. Well, if you look up the word similar in the dictionary, it means to have likeness or resemblance. Well, we were just saying in math, the similar figures are not the same size, but they are the same shape. So we could say similar figures have some sort of resemblance, or they have some sort of likeness. So let's get to some examples. Areas of similar figures. So as I stated at the beginning of this lesson, our scale factor is found by putting a ratio between our corresponding sides. So I see that AB and DE correspond to each other. So they tell me that these triangles are similar. That means that I know I can make this ratio. So I can say 6/9 is my K, or my scale factor. But it wants me to solve for the area of triangle DEF. Now we have to note that area is always in units squared. Well, the units that I just made a fraction out of are not squared. So in order to preserve that proportion, I am going to have to square my scale factor. Then I see I can fill in the rest of my proportion. Well, the area of ABC was 3 yards squared, so I'm going to put 3 there so that 6 and 3 correspond to the same triangle. And I know I'm solving for the area of DEF, so So I'll put that on the bottom as my x. These two are from the same triangle, so they're both going to be in the denominator. Now I can go ahead and solve this like I would any proportion. I can say 6 squared, or 36, times x by cross multiplying 9 squared, or 81, times 3. And now we're just working it out and solving for our variable. 81 times 3 gives me 243. And now I'll divide both sides by 36 to find the x, or my area, to be 6.75 yards squared. So the area is going to be proportional just like my corresponding sides, but we have to make sure we do the same thing. Well, if my units are squared here, then I need to make sure that I square my corresponding sides. Let's try another one. If you know the areas of both of them, so in this case we only knew the area of one and we were solving for the other area, this one I'm going to be given both of the areas. So trapezoid ABCD has an area of 20 centimeters squared. Trapezoid WXYZ has one that's 45 centimeters squared. So I'm going to use the same proportion I had before. I'm going to put the area of ABCD on top and the area of WXYZ on bottom. Now I know that those were both squared because they were both my areas. My units were squared. So I'm setting it equal to k squared. In my example up here, I did the same thing. I took my k, which was 6/9, and I squared it. Okay, so now I'm just going to go through and solve for my k. Well, first I notice that I can simplify this. I can divide top and bottom by 5, so I get 4/9 equals k squared. Now, to get rid of squaring, I have to square root. So the square root of 4 gives me 2, and the square root of 9 gives me 3. So my scale factor is going to be 2/3. The key here is you always have to simplify. If you think about any time that we've ever used our scale factor is always in simplest form. That way, we can easily take our square roots. Alright, so we are going to cross this out here. At this point, you can start your 11-5 assignment. Before you do that, I suggest that you check RenWeb and make sure that everything you turned in last week is graded and in, that I received it. Take care of that before you move on. So you'll go over section 11-5 homework tonight. Tomorrow you will have quiz 4, and then we will meet together on Zoom on Wednesday. But check and make sure that RenWeb is up to date, and if you have any questions, you